In yesterday's lecture, we had discussed about the suspension, that is one of the biphasic liquid dosage form. Now, the another biphasic liquid dosage form is emulsion. So, the learning outcomes, it includes definition, advantages and disadvantages of emulsion, classification of emulsion, identification tests of type of emulsion, that is test to identify which type of emulsion it is, and what are the ingredients or excipients which are used in the formulation of emulsion. So we'll begin with the definition of emulsion. So basically, as we had discussed in suspension also, these are biphasic liquid dosage form. Biphasic liquid dosage form means it consists of two phases, consisting of two immiscible liquids, one of which is dispersed throughout the other. Now in suspension, we had said that these are the biphasic liquid dosage form in which solid is dispersing liquid, whereas in case of emulsion, there are two immiscible liquids. So one liquid is to be dispersed in the another liquid, that is dispersed phase is also the liquid and dispersion medium is also the liquid. And very important, the system being stabilized by presence of third substance called as emulsifying agent. So basically we had seen that in case of suspension, we need suspending agent, we need viscosity modifiers to stabilize the suspension. On the similar line, emulsions are being stabilized by presence of third substance, which is nothing but the emulsifying agent. Now, next, what are the advantages of the emulsion? So basically, emulsion, it is a mixture of two immiscible liquid. Now, two immiscible liquid, the best example is oil in water. So when we used oil soluble drug or when we used unpalatable oil, so they are very difficult to convert into the dosage form because they are water insoluble. So such water insoluble or oil soluble drug can be formulated or can be administered in the form of emulsion, because emulsion contains two immiscible phase. One of the phase is always oily in nature, so we can formulate the oil soluble drug or unpalatable oil in the form of emulsion. So another advantage, the rate of absorption is increased as the drug is dissolved in the internal phase and it is distributed as fine droplets. So that we had also discussed in case of suspension, as these are the liquid dosage forms. So of course the rate of absorption is increased. It is possible to incorporate two incompatible ingredients, one in each phase. Now we know that emulsion contains two immiscible liquid. One is your oil phase, another one is water phase, and both the phases are immiscible. So if you have two drugs which are incompatible with each other. Now incompatible means if these two drugs, they are showing some reaction when we mix both the drugs together. So you can incorporate such two incompatible drugs, one in oil phase of emulsion, whereas other you can put in the water phase of an emulsion. So that is one of the most important advantage of emulsion, that you can mix or you can incorporate two immiscible or two incompatible ingredients in the emulsion. Now another point is disadvantages of emulsion. So what are the limitations of emulsion? So of course, as emulsions contains two immiscible phases, oil is immiscible in water, so there are many issues related with the stability of emulsion, because there are chances of separation of two phases from emulsion. So the disadvantage is storage conditions may affect the stability. Means when you prepare your emulsion, when you keep your emulsion, say for example for a period of 24 hours, so maybe there are chances of separation of your oil phase and water phase. That means the storage conditions, in which condition you are keeping your emulsion for storage, so that may affect the stability of the emulsion. The another disadvantage being a liquid dosage form, emulsions are bulky. They are difficult to transport. Of course, as a liquid dosage form, it is very difficult to transport the emulsion and prone to container breakage. So these are the limitations of emulsion. Then classification of emulsion. So there are various classes of emulsion based on different categories. The first classification is depending on the type of dispersed phase. As we know that emulsions are also the dispersed system like suspension. One phase is called as dispersed phase, another phase is nothing but dispersion medium. So emulsions are classified first of all on the basis of type of dispersed phase into two types, simple emulsion and multiple emulsion. So simple emulsion, they are of two types, that is oil in water emulsion, water in oil emulsion. Now oil in water emulsion, the name itself indicate here we can see O by W emulsion means oil is considered as dispersed phase and water is considered as dispersion medium. So these are the emulsions in which oily liquid is the dispersed phase and aqueous liquid or aqueous what we can say medium is the continuous phase. And basically these emulsions are administered orally. So they are O by W emulsion. The second type of simple emulsion is water in oil emulsion, that is W by O emulsion. So the name itself indicates W by O emulsion is nothing but aqueous liquid is your dispersed phase and oily liquid is the continuous phase. And these are mainly used for external applications. Say for example, now oil is the external phase. So these emulsions are oily in nature because external phase, what we can say, it is 80%, whereas internal phase is 20% in this biphasic liquid dosage form. So as oil is the external phase, so these emulsions are basically oily. So mostly these are used for external application, like say for example lotions, creams. These are the examples of emulsions which are the type of water in oil emulsion. Now depending on the type of dispersed phase, the another class of the emulsion is multiple emulsion. Now multiple emulsion means there are again two types of multiple emulsion, O by W by O emulsion and W by O by W emulsion. So O by W by O emulsion means these are the emulsions in which the aqueous phase is enclosed between two oily phases. So if here we can say that again your external phase is oily phase, whereas in between those two oily phases there will be the incorporation of aqueous phase. So that is nothing but O by W by O type of emulsion. The another type of multiple emulsion is W by O by W emulsion, in which the oily phase is enclosed between the two aqueous phases. So here we can see that W by O by W emulsion means whatever your external phase is there or whatever your dispersion medium is there, that is water. So in between those two water phases, we have incorporated the oil. Then second type of emulsion is depending on the size of droplets. Now in case of suspension, if you remember, we have said that the size of particle is very, very important. That is, it should be between 0.5 to 3 microns. Similarly, in case of emulsion, as it is a mixture of two immiscible liquid. So oil is there, water is there. So in case of emulsion, we say that droplet size should be minimum. Now, depending on that size of droplet, there are again two types of emulsion, micro emulsion and macro emulsion. Now, micro emulsions are nothing but micellar emulsions and they are translucent and transparent. So these are also called as micellar emulsions, which are translucent and transparent in nature. They are having droplet diameter in the range of 10 to 200 nanometer. They contain droplets of oil dispersed in water or water dispersed in oil. Means micro emulsion, it may be O by W emulsion, it may be W by O emulsion. But what is very important, the diameter of your droplet is between 10 to 200 nanometer. So diameter is in, if you can see, it is in the nano scale. So therefore they are called as micro. Whereas second type of emulsion based on the size of droplet is macro emulsion. Now these macro emulsions, they are again classified as fine emulsion and coarse emulsion. So fine, if we can say, fine means again the particle size is very less, whereas coarse emulsion, the particle size is higher, or we can say droplet size is more. Now as compared to micro emulsion, the macro emulsions are milky in appearance, whereas when we can say the size of droplets, or we can say the particle size of droplets. So fine emulsions have a droplet diameter in the range of 0.5, 0.1 and 5 micron. So if we can see, in case of micro emulsion, the size range is 10 to 200 nanometer. That's why they are called as micro, whereas macro means the droplet size is somewhat bigger, that is in between 0.1 to 5 micron. Then third class of the emulsion is depending on the physical state. So depending on the physical state, emulsions are classified as liquid emulsion and semi-solid emulsion. So semi-solid emulsions are also called as creams. Now what are liquid emulsions? So these are used orally, parenterally or externally. Say for example, oral emulsions, we have already discussed O by W type of emulsion in case of simple emulsion, as water is the external phase. So those emulsions are being used by oral. And if the external phase is oil, so these emulsions are being used by or for external applications. The dispersed phase may be or must be very finely dispersed, and those are the emulsions for parenteral use. And the emulsifying agents, whatever which we are using in the emulsion for its stability, must be non-toxic. The second type of emulsion, depending on the physical state, is semi-solid emulsion. So these are the external preparation, of course, because these are the creams which are to be applied by external application. So these are external preparations and which may be of O by W type or W by O type. But mostly they are W by O type because most of the creams are oily in nature instead of aqueous. So mostly they are W by O type, and sometimes the aqueous creams are also there. So they are the O by W types of emulsion. The fourth type of emulsion or fourth classification of emulsion is depending on the route of administration. So there are again two types: internally administered emulsion as well as externally administered emulsion. Now, if the emulsions are administered by oral route, that is internally, of course, these are O by W type of emulsion. Whereas externally administered emulsion, these emulsions basically comprised of liniments, lotions and creams. So they are either O by W type or W by O type of emulsion. So these are the four classes of emulsion depending on the size of droplet, depending on the physical state, depending on the route of administration. Now next very important part is identification test of type of emulsion. Now we know that there are main two types of emulsion, that is O by W type of emulsion and W by O type of emulsion. But how will you identify which type of emulsion it is? So there are various tests which are used to identify the type of emulsion, in which the very first test is miscibility test. Now the name itself indicates miscibility test. So what is its principle? Dilution of emulsion with external phase maintains the physical stability of your emulsion. Now, what is the method to check the type of emulsion? So, dilute the test emulsion with water. Now, if the emulsion is not showing any separation of water phase, so of course it indicates it is an O by W type of emulsion. Now, O by W type of emulsion means your external phase is water. So if you dilute this O by W emulsion with water, so of course it will not break or it will not separate. Whereas if you dilute your O by W emulsion with oil, so of course as external phase is water, but you have diluted that emulsion with oil, so it will break. So it is very important test for identification of emulsion, that miscibility test. Means if we have miscible or if we have dilute the emulsion with the water, so it will, if it will not separate, that means water is your external phase. The second test for identification of type of emulsion is fluorescence test. Now the principle, as we know that when we compare water and oil, so oil fluorescence more than water when we expose that emulsion to UV light. So what is its method? The emulsion is observed against UV light under microscope. Now we know that as oil undergoes fluorescence when is exposed to UV light. So if your emulsion is W by O type, of course the external phase shows the fluorescence. Whereas if your emulsion is O by W type of emulsion, there is no fluorescence, or we can say spotty fluorescence is observed when your emulsion is O by W type of emulsion, or when your external phase is water. So in this test, we have to remember oil shows the fluorescence. So when your emulsion is W by O type of emulsion, that means it shows the fluorescence. If your emulsion is O by W type of emulsion, now water is the external phase. So that means there is no fluorescence. There is only the spots are undergoes the fluorescence. Then the third type of test is color test. So what is the principle in this color test? Water phase or oil phase shows coloration when an emulsion is triturated with water or oil soluble coloring agent. Say for example, what is the method we'll see? Triturate the emulsion with oil soluble dye and observe under microscope. If the internal globules appeared colored against the colorless background, it indicates oil in water type of emulsion. Now see, both the phases, that is oil phase also shows coloration, whereas water phase also shows coloration. Now suppose if the internal phase, that is what globules, if they appeared color against the colorless background, it indicates oil in water type of emulsion. Whereas if droplet remains colorless, it indicates W by O type of emulsion. Means basically as compared to water, the oil shows more, what we can say, the color. Say for example, here we have said that if we triturate your emulsion with oil soluble dye, of course that dye is oil soluble, or of course that coloring agent, whatever we are using, it is soluble in oil. So it, of course, or it ultimately shows the color to that oil globules. That's why your emulsion is O by W type of emulsion. And if you are using, on the other hand, water soluble dye, so what will happen? It gives the color to those water soluble droplets. Okay, in that case, your emulsion is W by O type of emulsion. Then the fourth type of identification test is conductivity test. So we know that water is good conductor of electricity. So of course, immediately we can say that our emulsion, if there is the current passes through your emulsion, that means it is O by W type of emulsion. Means we have to immerse a pair of electrode in an emulsion and circuit them to lamp an electric potential. So if under whatever the applied current is there, if your lamp glow or if the current passes through that emulsion, it indicates it is O by W type of emulsion, or water is your continuous phase. And the fifth type of identification test is cobalt paper test. Now, anhydrous cobalt is blue and hydrated cobalt is red. Anhydrous, what we can say, suppose it is oil soluble. Okay, and hydrated means when that cobalt paper we have added into the water, or when that cobalt paper will come in contact with water. So that is nothing but hydrated. So what is the method? How to identify the type of emulsion? So you have to treat your filter paper with cobalt chloride solution and dry that filter paper. Now after drying, dip the paper in an emulsion. The color change from blue to pink. Now blue is for what? It is for anhydrous cobalt. Okay, that is not soluble in water. So if your filter paper or if your color of that filter paper changes from blue to pink red or blue to red, it indicates that your emulsion is O by W type of emulsion, because hydrated cobalt means what? It is towards the red color. So that's why that is nothing but, if your color of your paper changes from blue to pink red, it indicates the emulsion is O by W type of emulsion. So these are the various tests for identification of emulsion. Now the next point is formulation of emulsion. Now we know that formulation of emulsion means what excipients or what ingredients we are using into the preparation of that particular dosage form. So very first ingredient in all the dosage form, not only the emulsion, is drug, which API you are using. So as these are the emulsion, both the phases are liquid phases and one phase is immiscible with another phase. So mostly in case of the emulsion, oil itself acts as a drug, because oil is the one of the important ingredient in the formulation of emulsion. The second excipient or second ingredient which have used in the emulsion is oil phase. So apart from the therapeutic benefits, it can also be used to dissolve oil soluble drug. As in the beginning we have discussed in the advantages also, mostly we can formulate or we can prepare the dosage form of oil soluble drug using the emulsion or in the form of emulsion, because emulsion contains the oil. So therefore, apart from its therapeutic benefits, it can also be used to dissolve many of the oil soluble drugs. Then along with that, the oil phase provide emollient effect, especially in external applications or especially in external preparation, for example lotions as well as creams. Then third ingredient or excipient which is used in the formulation of emulsion is aqueous phase. So water is generally used as aqueous phase. Of course, there are two phases. One is oil, another one is water. So water is used as the aqueous phase in the preparation of emulsion. However, in some emulsion, cinnamon water have been used as the aqueous phase. So instead of normal water or distilled water, many a times cinnamon water can also be used as the aqueous phase in the formulation of emulsion. The water soluble drug, if present in your emulsion, they are first dissolved in the aqueous phase and then they are to be mixed with the oily phase. Then the next very important ingredient in the emulsion, which is basically used for stability of emulsion or to maintain the stability of emulsion, is emulsifying agent. So there are various categories or various classes of emulsion. Very first category of emulsifying agent is polysaccharides. Now again under the polysaccharide, some are the natural polysaccharide, whereas some are semi-synthetic polysaccharides, some are synthetic polysaccharides also. So what are the natural polysaccharides? Basically, these hydrocolloids form O by W type of emulsion. Now, how they will be responsible for stabilization of emulsion? So they will form O by W type of emulsion. They form a multimolecular interfacial film around each oil droplet. As they form the O by W type of emulsion, so water is the external phase. Now, how that water should be your external phase, because these natural polysaccharide, how they will be responsible for stabilization of your emulsion, or how they are using as an emulsifying agent. So their role is to form a monomolecular or multimolecular interfacial film around each oil droplet, so that that oil droplet gets easily dissolved into your water phase. They increase the viscosity of water phase. Of course, these are the polysaccharides. They have some viscosity, so they increase the viscosity of water phase. And the example of natural polysaccharide is acacia. It is most frequently used natural polysaccharides for oral emulsion. Now, the another type of polysaccharide is semi-synthetic polysaccharides. So these are used as O by W emulsifying agent as well as stabilizer. So they are considered as emulsifying agents also. They are considered as stabilizers also, because their role is to stabilize the emulsion, to increase the viscosity of emulsion. Low viscosity grades of methyl cellulose are suitable as emulsifying agents. So under semi-synthetic polysaccharide, the example is sodium carboxymethyl cellulose as well as methyl cellulose. Both are used as emulsifying agents. The second type of emulsifying agents after polysaccharides are surfactants. So you all know that what are surfactants basically. So surfactants are nothing but the surface active agent. What is the principle or what is the role of surfactant or surface active agent? So they reduce the surface tension between both the phases. Now in case of emulsion, we have oil phase and water phase. So that oil droplet, it is not going to dissolve in the water phase because both are immiscible. So we are using surfactant to solubilize that oil with the water. Why? Because these are amphiphilic molecules. Surfactants are nothing but these are amphiphilic molecules, and they have both the hydrophilic as well as lipophilic group. So these surfactant molecules are basically used because they lower the surface tension between oil phase and water phase, and your oil will immediately get dissolved in the water to form a stable emulsion. Now, there are three types of surfactant: anionic surfactant, cationic surfactant, non-ionic surfactant. Now, what are anionic surfactant? The name itself indicates anionic surfactant means in water or in aqueous vehicle or aqueous solution, they dissociate to form a large anion which is responsible for its emulsifying activity. They are cheap, but due to their toxicity, they are used for external emulsion. So they are not used for the emulsions which are to be taken by oral route. The examples of anionic emulsifying agents: sodium stearate, calcium oleate, triethanolamine stearate. The second type of surfactant is cationic surfactant. Now, name itself indicate again, cationic surfactant means they will undergo the ionization and they will form a cation responsible for their emulsifying ability. Now, these cationic surfactant, they produce O by W type of emulsion, are unstable at high pH, and they are incompatible with anionic surfactant. So we cannot use the cationic surfactant and anionic surfactant in combination. They are used as disinfectant and preservatives also. Example is cetrimide. The next is non-ionic surfactant. So non-ionic surfactant, they don't have any charge, so they does not ionize. They are non-toxic or non-irritant, therefore they can be used orally as well as parenterally. So in comparison to anionic surfactant as well as cationic surfactant, as these non-ionic surfactants are non-toxic, non-irritant, so therefore they can be used orally as well as parenterally. The example of non-ionic surfactant include span, twin, and glycerin monostearate. Now, after surfactant, many a time finally divided solids are also being added into the emulsion. They also been act as emulsifying agent by forming a thick, impenetrable particulate film. Mainly, the class of clays are nothing but the finally divided solids. Now, clays, of course, they are having some viscosity. So they can be used as stabilizers in lotion as well as cream types of emulsion. For example, bentorite as well as hectorite. These are the example of clays which are used as emulsifying agent or which are used as stabilizing agent. Now, another excipient or formulation ingredient added in emulsion is antioxidant. Very important ingredient because we know that emulsion, these are biphasic liquid dosage form in which one phase is oil, another phase is water. Now, whenever there is oil, so there are chances of depolymerization, or we can say there are chances of oxidation. Oil undergoes oxidation at faster rate. So we have to add antioxidants in emulsion. So it is used in formulation and it should be compatible with drug and excipient. So whatever the antioxidants which we are using, it should be compatible with your drug and excipient. Now, what are the examples? BHA, that is butylated hydroxyanisole, BHT, butylated hydroxytoluene, ascorbic acid, and tocopherol. These are some of the examples of antioxidants which are to be added in emulsion. The next ingredient, preservative. Of course, we say that emulsion, again, it contains water. So there are chances of microbial contamination. So we have to add preservative to avoid that microbial growth. So examples of preservative, methyl paraben, benzoic acid. Now, after preservative, if you increase the palatability of your emulsion, if you want to increase the acceptability of your formulation, we have to add the organoleptic additives. Like say, for example, your coloring agent, sometimes we are adding flavoring agents also. So flavoring agents may be incorporated in the emulsion in order to mask the unpalatable tastes of oil. Say, for example, one of the flavoring agent is peppermint oil. And if you want to increase the aesthetic properties of your emulsion, you can use coloring agent also. Then the very important ingredient is buffer, because many of the emulsions we had said that they are applied externally. They had to be applied on the surface of skin. Say, for example, your cream, lotion. So whatever the emulsion is, that it should be compatible with your skin pH. So it is very important to maintain the pH of your formulation. So that pH can be maintained by addition of buffers into your formulation. So basically, these may be added to maintain the chemical stability of the drug, or to control the tonicity, or to ensure physicochemical properties or physiological compatibility of your formulation. But Basic role of buffer, as we know that it is used to maintain the pH of the formulation. So many a time phosphate buffer, borate buffer, acetate buffer, these buffers we can use in the preparation of emulsion. The next ingredient is density modifier. Now, in the suspension chapter, we had discussed Stokes' law. So it can be seen that if dispersed phase and dispersion medium both have same densities, then the creaming will not occur. Because we know that in case of emulsion also, like that of suspension, there are chances of creaming, there are chances of cracking, there are chances of phase inversion. So to avoid this, we have to maintain the densities of both the phases same, or we have to maintain similar densities of your dispersed phase as well as dispersion medium. So therefore, it is necessary to add density modifier into your emulsion. So example of density modifier, glycerol and sucrose. Understood? So these are the various formulation ingredients which are to be used in the formulation of emulsion. Thank you.